I can see attendees have started joining us. Thank you all the attendees for taking out time from your busy schedule and joining us today. Can I request my team to start with the sponsor videos?
Hello, everyone.
Hello, sir. Attendees have started joining us, so you have to mute yourself.
Sure.
Thank you.
हाँ बॉस, आवाज आ रहा है क्या?
Ganges International Private Limited continues its legacy to be the leaders in manufacturing and installation of module mounting structures through its commitment, innovation, and quality, and has already executed over 6 gigawatt of installations pan-India. Ganges International now brings in the latest in single-axis tracking systems in India in partnership with Dragon Sol, one of China's most experienced tracking system providers. Dragon Sol was the first company in China to successfully develop a dual-axis tracking system. We have worked with CPP, one of the most recognized wind engineering companies in the US, to conduct a wind tunnel report on the Dragon Sol tracker, and the results show that Dragon Sol's patented HALM technology divides the entire system into subunits and creates a multiple point drive for every subunit to avoid wind-induced resonance. We emphasize modular design to minimize on-site installation efforts. The unique design allows the trackers to follow the land contour. As seen in the video footage, which is from our live pilot plant, Dragon Sol structure is one of the longest independent solar trackers in the world and can extend up to 200 meters in length with up to 400 modules. The long length of each tracker also enables movement of robotic cleaners on the modules. Dragon Sol trackers can be installed on either portrait or landscape modules and are compatible with both monofacial and bifacial configuration.
Hello everyone, a very good afternoon. I'm Sangeeta and it's my pleasure to welcome you all virtually on behalf of Solar Quarter and First View Group with our event on PV Mounting Tech Structure and Tracker Technology Forum. Solar technology is currently the fastest growing generation technology, and substantial investments are poured into technology development due to the rise in demand in solar sector. The foundations of structures on which the whole solar project rests is increasingly becoming important, and changes in design and material are happening globally as well as domestically. The virtual conference today, we will discuss the latest technology advancements, minimum qualifying criteria and selection, most suitable types as per Indian solar market, and cost trends for mounting structures and trackers for both utility and rooftop solar projects. We will also discuss the best combination of module tracker for achieving highest power yield. I would like to thank our sponsors, Platinum Partner Artec, Gold Partners Ganges International Private Limited and RRS Part Limited, Silver Partner ASIN Trackers Private Limited. Let's begin with our first techno-commercial presentation by Mr. Ganesh Rai, who is the Head of Technical Sales Support from Artec. Over to you, sir.
Good evening, Sangeeta. Can you please allow me to share my screen?
Yes. Access given to you, sir.
Yes, thank you so much. Hope you are able to see my screen.
Yes, perfect. Thank you.
Good evening and thank you everyone. It's absolutely privilege with you here today. I am Ganesh, Head of Technical Sales Support for Artec India. I would like to start with today with the hope everyone in the call and their families are staying safe. I know it's a tough time, but keep faith and I'm sure things will get back to normalize quickly. So let's start with the tracker presentation. So Artec is founded in 2009, our headquarters in Kunsan, China. So far, we have 1,000 plus employee. Installation capacity, tracker plus fixed tilt is approximately 32 gigawatt. We have so far 1,100 plus projects, and that's situated in 40 plus countries. So this is the history and milestone of ArcTech. As I already mentioned, company founded in 2009. And from 2009, we are continuously developing different products in the tracker segments. So in 2014, we launched our first ArcTaker Pro, that is our block tracker solution. And in the same year, we entered UK as well as Japan market. And 2015, we entered in the India market and we become number one. We receive many big projects in India. In 2016, we become number one in the APAC region and top 5 in the worldwide. 2017, we launched our first independent row solution, that is Sky Smart, that is 2-piece solution and especially designed for the bifacial module. In 18, we launched Skyline, that is our 1-piece solution. And in 1-piece solution, that is also fully compatible with the bifacial. And in the same year, we become number one structure supplier in the worldwide and top 4 tracker supplier in the world. 2019, we launched our Sky Smart 2. That is an advanced version of Sky Smart. And that is also 2-piece solution. And in the same year, we become number one tracker supplier APAC region. And in the last year, we listed a company in the Shanghai Stock Exchange. And now this company is Shanghai Stock Exchange listed. And in the last year, we received 2 big projects. One from the Middle East, 575 megawatt. And another project we received gigawatt scale in India as well. And these are our goal presence. We have so far 11 plus overseas branches and 4 service centers. In India, we have office in Gurgaon, sector 49. These 3 are production facilities we have. We have 3 huge factories in China, 1 factory in Jiangsu, another factory is in Kunsan, as well as another cities in China. So we have 3 huge factories in China. So in the tracker segment, we have 2 main products. One is Skyline, which is 1-piece solution. It's fully independent solution. Another is Sky Smart 2, that is 2-piece solution. And recently our R&D is also working on this Skyline 2 model. That is the advanced version of Skyline 1. And in the coming days, we will launch that product as well. So that product is also next generation of our 1P tracker. So here we have multiple slewing drive system. So that will give us more strengthening in the tracker design. This is the Skyline 1. Here tracker length is up to 105 meter and width is up to 2.7 meters. So this is fully compatible with the latest module, which now available in the market, where module lengths are approximately 1.35 and width 1.35 is the width and 2.23 is the length. So it's fully compatible with the latest module technology. Here we are offering 1v5 solution. So all the 5 trackers are connecting together. Slope adaptability, we have approximately 15%, which is the most advanced we are offering. Other competitors have approximately 10 to 12%, but we are offering 15%. Higher GCR, because some of the suppliers don't put module in the top of the ports, but in our solution, we are continuously installing the module. So we don't have any gap for the bearings. So you will get additional GCR. This is the Sky Smart solution, that is 2-piece solution. So it's come with a multi-point drawing system. So here we have a shorter spar and cantilevers, and due to that we have small deflections as well. And this Sky Smart solution is the first solution which received IEC 62817. All the tracker suppliers who have this IEC 62817, that is with single fixed point. But we are the only supplier who have multiple slewing drive and who have this IEC certificate. Other than that tracker, we are also providing SCADA system. So we launched this SCADA system in last year. And this the basic advantage of this SCADA system, client will get all the related tracker related parameter in one place. You are able to control all the tracker from one place. You will get all the data in one place. Even if any alarm raise, you will get access from the SCADA portal. Easily you can control, easily you can record all the tracker related difficulties. You can access from this SCADA. This is another product which we are offering. We have our own robotic solutions, which is fully compatible with 1P as well as 2P solution. And here our cleaning technology is breast without water. So it's a totally dry solution. There is no water required. Here we are using LoRa technology, which is most advanced technology. It allows us up to 8 kilometers of long range for the communication. This is the advanced algorithm which we launch, and here basically you will get additional 2 to 6% of additional gain. So basically what is happening, if you have a lens which is very slow, so early morning and late evening, there is a shadow fall. If you see here in the first picture, there is a shadow in the early morning and late evening, but because of this AI controller, you can avoid this shadow and you will get additional 2 to 6% of additional gain. This is the wind tunnel tests. So we carried out our wind tunnel test from the CPP, that is the most renowned company, US based company, and all our tracker models are tested by CPP agencies. So there are multiple labels, multiple categories which many companies are performing. So if you see here, most of the companies have label 1 only. So label 1 is for static, level 2 for dynamic, level 3 for stability, level 4 for aeroelasticity. So different level, different companies are performing. But in the level 5, we are the only company who is doing this level 5 analysis. So level 5 is what? So level 5 basically what is happening? So here basically we are measuring all the load and moment coefficient directly from the deflected shape of a realistic tracker model. So that means whenever trackers are stable, so we can, in the same time, we can measure the moment as well as deflection. So at the same time, we can do both the things. So these things only we are doing along with the CPP. So this is something we only have. In India, we have so far 850 plus megawatt Arctaker Pro. That is our linked solution. Earlier we supplied. And 80 plus megawatt of Skyline, that is come with a bifacial solution. And under construction, approximately 1.7 gigawatt, that is also with bifacial module. These are service support. We have team who is providing 24/7 support. We have professional engineering team who is doing calculation and reports. For financial analysis, we also have team. For the on-site support, we have 20 plus engineers team who is helping us for POT as well as installation services. For the cloud platform, we have team located in Shanghai. They are sitting there and they are working 24/7 for the cloud platform support. This is the team in India. So we came India in 2016, and in this year we are celebrating 5 years. We have 20 plus engineers who is supporting site related activities. We have local managers for the local contact window. So far we have 2 warehouses, Gurgaon and Hyderabad, and very soon we are going to launch a warehouse in Rajasthan as well. So this is the conclusion. So we have R&D leadership who is they are continuously working. Our CTO, Mr. Bruce Wang, is also the member of IEC committee. So we have a strong R&D support. Powerful production capability. So we are continuously developing different products. Like I already explained you, we have robots, we have SCADA, we have different type of trackers. Extensive network, I already mentioned, we have presence all around the world. Product portfolio already explained. Successful track record. So in India, we have approximately 2 gigawatt of tracker projects so far. So that's all from my side. If anyone have any question, maybe we'll discuss during Q&A section. Thank you so much.
Thank you so much, sir, for the valuable insights. What we will do is we will take up the questions a little later.
Sure, no problem. Thank you.
With this, we will proceed ahead with our next techno-commercial presentation by Mr. Santosh Patil, who is the business head from Ganges International Private Limited. Sir, the screen is all yours.
Thank you, Sangeeta. And good evening, everyone. I am Santosh Patil, business at Ganges International, taking care of the solar division. Hope all of you and your families are safe and healthy and continue to do so. Today, we are going to present our single axis tracking system designed by our partner Dragon Soul of China. First, would like to give a brief about Ganges and Dragon Soul. Ganges International, with over 6 gigawatt peak of solar projects installed, is one of the largest solar module mounting manufacturing company in India, and the project execution wherein we do the complete DC side supply and installation work with free issue of modules and inverter from our customers. We have a MMS manufacturing facility at Pondicherry with a capacity of 1.8 lakh metric ton per annum. About Dragon Soul. Dragon Soul is one of the pioneers in developing and installing dual axis tracking system. And thereafter, they have more than 600 megawatt installations in China. The current design, what we are discussing, was launched in September 2019. Next. What comes to mind when we think of which is the safest structure for a module? It is undoubtedly the fixed tilt structure. You can talk to any developer and they are more confident in putting up a fixed tilt solar plant, considering the safety and rigidity it offers. But increase in equipment and module cost and decrease in tariff has compelled everyone to look for other alternatives to lower the LCOE, and developers are now looking at single axis tracker. Next slide, please. Keeping in mind the safest structure, that is the fixed tilt, Dragon Soul has developed a unique tracker wherein multiple tables like fixed tilt of the configuration either 2x10 or 4x5 are run by a single drive with a patented HALM technology. Since the tables are just 10 meter long and design is similar to the fixed tilt, they are more rigid and has excellent dampening effect. The video, please. You can see it has two columns. Each table has two columns, rafter and purlins with 20 modules. It is called a subunit, and many subunits can be put in, like 20 such subunits, 20 tables can be put in, and it will be driven by a single drive. We have a dual drive also, wherein this can continue up to 40 tables, that is 800 modules. We can say this is the drive which runs the tracker. The technology is HALM, that is hour angle longitudinal master. We have a live proto plant with 400 modules installed near Jaipur on June 2020. Anybody who wants to visit the plant can contact us and we're happy to take you there. We have 20 tables here with 400 modules being run by a single drive. The advantage of this tracker is the loads are transmitted directly to the post. It's a multi-point drive to avoid wind-induced resonance. HLM technology divides the system into multiple subunits, which transfers the torsional moment of the subunit into tensile force of the steel rope. Next slide. The video here of the actual site. You can see the bracings are circular bracings, and they are all HR rolled sections for greater stability. It is the longest independent tracker in the world, as already informed. Like 10 meter each subunits, we can go up to 40 tables. That is, it can go up to 400 meter long with 800 modules. With a single drive system, it can run 400 modules. With a dual drive, that with a single motor, it can drive 800 modules. Suppose you are using a 500 watt peak module. One row will be 400 kilowatt. Since these are small tables of just 10-meter long, the terrain adaptability is easy, and table to table gradient, 2.5-degree gradient is acceptable. So with minimum or no grading, we can align the row. Without grading also, it can run. Since this single axis tracker travels are installed like fixed tilt structure with a minimum gap of 50 mm when the land is flat and maximum up to 100 mm when there is undulation. The robotic cleaner movement is very easy with small bridges in between. It can just run the entire row without any problem. We have two types of table configuration, 2 in portrait and 4 in landscape for both bifacial and monofacial. Wind tunnel test has been done with CPP USA, the static load, dynamic load, and the aeroelastic instability. Just to give a snapshot of the wind tunnel test done, you can see Dragon Soul at 0 degree is completely straight. There is no variance. But you can see the other trackers. So it is immune to instability for wind speeds up to somewhere between 50 and 40 meters per second, regardless of the angle. The current design, the 20 megawatt, was commissioned in November 2020 in the Hebei province, and this is the actual site photograph. We are free to take questions next time.
Thank you so much, sir, for the valuable insights. So we will take up the questions after the first panel discussion.
Sure. Thank you.
Thank you. With this, we will proceed ahead with our next techno-commercial presentation by Mr. Varun Sachar, who is the Managing Director from ASIN Trackers Private Limited. Varun, sir, over to you. Sir, you'll have to unmute yourself.
Am I audible?
Perfect, sir. If you could please make your screen full screen, sir. This is not full screen.
Okay. Now it's okay?
Perfect. Thank you.
Yeah, good afternoon to everyone. And all I can say is please be safe during this pandemic. It is very horrible. Anyways, let me take this opportunity to present about my company called ASIN Trackers. Well, ASIN per se is already into the market past 8 to 9 years. We do a lot of rooftop installation. So this is a new division which we started off in 2016 to be precise. And we have developed a disruptive technology. And let me just go through down to the presentation and show you what this product is all about and how did we get this idea. Well, this is the growth of the solar power, needless to say, mentioned to anyone in this industry. And another, the cost of solar, where people keep working upon it, the levelized cost of energy, which used to be something very impressive, around $100 per megawatt hour in 2015 has dropped by 50% in 2020, and it has further dropped in some of the countries. And the tariff, you know, the way it is depleting with every tender bid. So this becomes a matter of concern for the developers today. And the people are, the developers are more concerned about the interest rate, the cost of the modules, which is fluctuating every day. And past 1 year, I've been seeing a lot of fluctuation in the prices. And ultimately, what a customer is or developer is looking for is the CUF. And that becomes the single largest factor in the comparative play for the developers. There has been a small study done by IEFA that if there's a 3% drop in CUF can result in over 7% fall in the equity return, which is quite an alarming situation. Now, the consistent increase in yield is the only way forward for higher CUF and improved IRRs because they are directly proportional to IRR. So we have to consistently increase the CUF. And how it is to be done? How is to maximize the yield? That is always a developer or an investor or IPP is looking forward for. So what we have done is we have gone back to our drawing board and we understood the sun path, and we also saw the various positions of the sun during the day, during the month, during the quarter, during the year. So these are some of the positions of the sun. The yellow arc which you see is the summer position of the sun, and June, mid of or in the third week of June, you get the summer solstice period when the sun is right on top of your head. And the red which you see, which is at the bottom, is the winter, during the winter. So somewhere in the third week of December, the sun is far away from the earth and it is towards the south position. The orange arc which you see is basically the transitional period. These are the equinox period, which happens somewhere during the month of March and during the month of September. So we are trying to address this position, these positions, because we know for the fact that the amount of electricity generated of a solar PV module is maximum when the angle of solar incidence on the module is perpendicular. The angle of incidence has to be 90 degrees, then only you will get the maximum output. And now the sun, as we all know, with this diagram, through this diagram, that the sun not only moves from east to west during the day, this east-west path also shifts along north-south during the year. Even in a day, there's a movement of the movement of the sun from north to south. But during the year, if you see it, somewhere in the end of the year, the sun is much, much below and more closer to the south. So it is higher during the summers and lower during the winters. So this is the philosophy which we have tried to copy. And let us see the prevalent options available in the structures we have. And they all follow and correlate this with the diagrams which I just showed you and explained to you. The fixed tilt, in this, no doubt they are the best, they are strong, undisputedly one of the best. The modules are fixed at an angle determined as per the location. We all know about it. So as to receive the aggregated near normal incidence. The generation is very nominal at this at one fixed position because the sun is moving from all the angles. Single axis tracker. Now the single axis tracker, there are two types of trackers available in single axis. One is horizontal and the other is tilted. Most widely used is the horizontal single axis tracker, which is the modules are mounted on the torque tube along the north-south axis parallel to the ground, and the modules move only from east to west, and it has got only one axis. The yield improves mainly during the summers when the path of the sun is perpendicular to the module. Then only you will get the maximum output. How about when it goes into the winters? We'll see that later. The third category is the dual axis tracker. Undoubtedly, it is the best solar tracking technology available in the market. But unfortunately, it is not economically viable. But the output from this particular technology is undoubtedly the best. Now, how How are these compared? The fixed tilt is obviously the low capital investment, low structure weight, no automation is there, no moving parts are there, no installation, low installation, low O&M, but the performance is suboptimal. So there is a drawback there. Single axis tracker, well, it does add some capital investment, high structural weight, added automation because it's moving, there are moving parts in it, increased installation and labor, it has got an O&M cost, but inconsistency in performance. I can prove that with all the data which I have with me. It's going to be higher in summer months, undoubtedly, because the sun is right on top on a horizontal module. But it falls in winters, often fall even below the fixed tilt. This has been observed, particularly at the locations above the Tropic of Cancer or below the Tropic of Capricorn in the southern hemisphere. Because the sun moves towards south and the angle of incidence on the horizontal panel is at an obtuse angle. It is not at a right angle, thus giving poor performance. The third dual axis tracker, which is available in the market, undoubtedly the best performing product, very high capital investment, very heavy structure, high automation, lot of moving parts, high installation and labor, high O&M cost, but the result, the output is good, best performance, because the alignment of panels to the path of the sun stays optimally throughout the year. But when we talk about the project cost, the levelized cost of energy, it fails. It is not the solution. So keeping all these three different MMS available to us, ASUN Tracker decided to get into a different venture, to get into a disruptive technology and design a tracking technology where it can remove all the obstacles or the shortcomings in the single axis tracker and gain the performance of the dual axis tracker. And this is the product which I would like to launch or showcase to the people, a dual axis performance at a single axis cost. This is a small technology, this is a disruptive technology which we have developed. And it is called two-axis tracker. We are not calling it as a dual axis tracker, but grammatically in the Oxford Dictionary, dual axis means two, but we are giving it the name as numerical two-axis tracker, which gives you a performance close to a dual axis tracker at the cost of a single axis tracker. Now, ASUN two-axis tracker overcomes the inherent disadvantages of the single axis design. It also addresses the key investors or developers' concern that prevalent adoption of trackers. The people were not using trackers because of this reason. Okay, well, there's an inconsistency. So let us look for, now when they get this solution, they will start opting in for trackers. By moving away from the 360-degree rotational design of a dual axis tracker, it opts for a economical and optimized two-axis movement. Now, we are also thinking how the investors' concerns are the structure weight, the ease of installation, O&M cost, consistency in performance. Whereas in single axis drawbacks are lack of seasonal shift, centralized design, controlling large number of arrays and modules in a row, low plant availability because of this, inconsistency in the performance, and low terrain adaptability. Now the product, which is a future-ready product, it is a highly optimized structure. It's modular in design for easy installation, high terrain adaptability. We go as high as 30 degrees. New material for low maintenance. We have developed some new technology in this, which I'll show you, share that you later. High and consistent performance in all seasons. Irrespective of the weather situation, in the season, it will consistently give you performance. Let's have some more details on this. The two-axis movement addresses all seasons of a year, which is very, very important. Thus, maintaining the angle of incidence close to 90 degrees. I'm not saying 190 degrees, but it's very, very close to 90 degrees. Highly optimized structural design, meaning low structural weight and high comparative cost. Decentralized design for ease of installation and higher plant availability. Modular configuration with proprietary coupling. We have designed a coupling system which can adopt the terrain adaptability, designed to withstand a wind speed of up to 170 kilometers per hour. Panel array configuration allows for maximizing the bifacial module efficiency, which I'll show you that how this technology is more beneficial for the bifacial modules. Self-lubricating polymer bearings for the minimum maintenance. We have got this bearings designed from DuPont and using the proprietary product by the name of POM. This is self-lubricating bearing. We don't need to do any lubrication of these bearings and it can last for 25, 30 years. IoT-ready product with features like remote monitoring system, self-diagnostic and troubleshooting. Suitable for installation on high gradient slopes like hilly terrain, etc. And increase yield by up to 28% depending on the location and the climatic conditions. Sangeeta, you have to give me some time.
So we are really running out of time.
I know, but this is the new product which I need to know. But let me tell you that this design has been developed by IIT Delhi. They have kept all the features into place and they have designed this technology. This is the plant, which is my plant in Roorkee of 2 megawatts. On the left-hand side is a single axis track, is a fixed tilt, which has got only one seasonal tilt. On the back of side is a horizontal single axis tracker. And in the front, you see the two axis tracker. So what I have done is, and this is on string inverters. So I have picked up the best performing inverters from the fixed tilt, best performing inverter from the single axis tracker and compared with the two axis tracker. And let me show you the result. It is very, very astonishing. And this is the result what we get. The first year, incident-free operation points to an overall increase of 20% at a location in Roorkee. And I challenge any other tracking technology to give me that particular yield. Seasonal tilt and 13.5% over single axis tracker. Now this graph shows you, we did the data collection from 1st of January till 31st of December. And on month-to-month basis, we have compiled this data which shows you that the yellow line is the single axis tracker, the gray is the fixed tilt. So the yellow line is going below the single axis tracker at least 3 times in a month. That is November, December, and January. And during the equinox period, that is somewhere in October and in March, they're intersecting. So they're at par. Whereas two axis tracker is always higher. So there's a consistency in performance. Let me try to demonstrate this graph in a different format. This is another format. We are keeping the performance of a fixed tilt as delta. And yellow being the single axis tracker, which shows that in 3 months again, it's giving you low performance below than the delta. And two axis tracker is giving you higher performance. Let me cut short on this and let me show you a small video on this. Let me show you the functionality of this. Sangeet, I'll take a couple of seconds, minutes more. This is the tracker. This is on a prototype tracker. Please don't mind the photography of this because we are a startup company and we have achieved this. So here you can see the module is moving towards east in the morning and the table is moving towards south. So there are two movements, east-west as well as north-south. So as per the position of the sun, it is moving down towards south of a particular time in a day or in a month. And here you see the movement which is happening. if you see the sun path, it forms a parabolic curve which moves down in the south and then goes back again towards the north. So this is now lifting back, and in the night it will come back to the stow position. So there are two movements happening simultaneously. And this tracker can hold a wind speed of 170 kilometers per hour. We have done CFT analysis. Everything has been done on this, has been tested. Now, looking at the design of this two-axis tracker, I'll try to explain you that how this can be more beneficial for the bifacial modules.
Sir, I'm so sorry, sir. We have to end.
This is the
because
last slide. This is the last slide. This is the last slide.
Thank you so
Okay.
much.
Sorry, Sangeeta. So this is some of the positions which we have tried to find out the sun rays which is falling on the ground and then falling on the back of the module. Gap between the panels allow for the more radiation to bounce off the ground below the tracker. And on the right hand side is the radiation reflected off the top surface of one panel can be captured by the bottom surface of the next. So there's a reflection from the panel to the panel. So that's how this design is made in such a way that it is an ideal product for the bifacial module. Thank you very much, gentlemen, ladies and gentlemen, for giving me this time. Any questions that can be asked in the Q&A session? Right, Sangeeta?
So sorry for the interruption, sir. Thank you so much for the valuable insights. We will take up the questions a little later after the first panel.
Sure. I look forward for that.
Thank you. With this, we will proceed ahead with our first panel discussion on structures, trackers, and mounting systems for utility projects. Session experts who have joined us today are Mr. Amresh Mahajan, who is a VP from O2 Power Private Limited, who would also be moderating today's session, Mr. Rishi Mishra, who is a Vice President from Ashar Power, Mr. Santosh Patil, who is a business head from Ganges International Private Limited, Mr. Ganesh Rai, who is the head of technical sales support from Arctic, Mr. Sanjay Narula, who is a business head, India Solar Business from Hindustan Clean Energy Limited, and Mr. Dinesh Thakre, who is the head design and engineering from Clean Max. I would like to hand over the session to Amresh sir to take the discussions forward with other speakers. Thank you.
Thank you, Sangeeta, and good evening to everyone. So before we start, I think let's spare a thought for everyone who are battling in this pandemic, and also pay our homage to people who are no more in this world. So possibly they are in a better place, but let's hope this pandemic ends very soon and we return to our normal lives. Also spare a thought to each and every one of the utility people who are working to keep our power plants running, whether it is thermal, whether it is hydro, and whether it is solar power plants. So let's pay tribute to each and every one of them. So let's start with the discussion. I think we have a very elite panel present here who can show light on this wonderful and very pertinent topic, the solar structures as well as the trackers. So basically, my understanding is the way solar has shown comprehensive increase in, you know, last 10 to 12 years in terms of installation, whether it is ground mounted, whether it is rooftop. My understanding is that the increase in trackers has not been in the growth of both has not been aligned. So there might be certain reasons for it. So let's ask our panelists what could be the reason whether the growth in the trackers in India is comparatively lesser than the growth in the grid scales projects. I'm sure there are see when something is not growing that substantially, there can be three reasons for it. One can be the technology, other can be the price, and third can be the compatibility. So when I say compatibility, it's the compatibility of the trackers with respect to Indian environmental conditions. So let's ask from our panelists what they think about it. So I'll be slightly biased because in the panelists, so I can see Mr. Sanjay Nurullah, who happened to be my reporting manager for many years. So I would like to go first to him. So Mr. Sanjay Nurullah, so welcome, and I'd like to hear from you. So, what could be the reason in this disparity in the growth of Indian trackers as well as the grid scale projects? This is number one. And secondly, uh, in your view, how do you see the Indian tracker industry keeping in pace with the projects coming up, and whether it is really related to quality, whether it is related to pricing, or it is related to some conditions? For example, the earlier projects were in Gujarat or somewhere else, but now with Rajasthan coming in top three, so whether this mismatch will be set right? So what are your views on that?
Oh, thanks. Thanks a lot, Amaresh, for connecting with me on here. I think otherwise we don't meet, but this is the plate at least we have met after a long time.
Yes, sir.
So nice to see you here. So the first question that you asked is very pertinent as to why the growth of solar as well as trackers has not been congruent, in a sense that solar grew a lot, but the trackers didn't grow at all. I believe it was the learning phase of the Indian industry, wherein, when we started installing solar way back in 2010, the structure itself was a kind of a new thing for Indian industry. So some of the initial structure itself that were installed in the early projects were way different than the projects that we have today. There used to be projects which would measure as much as 50 tons per megawatt. They were Herculean, very heavy structures that were installed up in the beginning because people were very cautious, and then over time efficiency improved and the Indian industry learned, and right now we are at about 24-25 megawatt kind of a fixed ton per megawatt in terms of fixed tilt structures. Now, in the initial few years, in spite of being there in the industry had not much heard or learned about single axis tracker or dual axis tracker. They would have heard of it, but nobody ventured into this because it used to be expensive. Whenever you would do a financial cost benefit analysis, you would find that structures are close to 1.2 crores kind of per megawatt. It was a prohibitive pricing that was attached to it. It was more than a crore at that time, so you would never talk about it. Then there was a time around 2014-15 when there were certain Indian players like Smart Track. At that time, I heard of that company. I visited other places. Smart Track, Scorpius Trackers, and couple of others. Mahindra started after that. Those people started to deploy trackers. And that was more so in southern India because people found that in southern India, while on the northern side, you could have about 13-14% gain through single axis tracker. In the southern India, you would have as much, you can hit 20%, cross 20% mark. So that's how it started. And then a lot of indigenization and competitive pricing. I think it's the commercial perspective which is coming into place over time. And now, as on today, if somebody is not installing single axis tracker, that needs to be questioned. The wisdom of that developers seems to be, it needs to be argued out as to why are you not installing single axis tracker with bifacial module, which gives you the best LCOE value. So I think timings, it was the learning curve, I would say. It was a learning curve, but right now we are at par with what it should be. And a lot of traction for single axis tracker now. So people in the middle somewhere started using seasonal tilt, also manually seasonal tilt. So that was a local jugaad. for Indian industry to do something on north-south basis. But eventually, I think now we are getting the point now. Indian industry has evolved, and now we find merit, and most importantly, cost competitiveness. Now installing, while the module prices at some point of time, installing 20% of additional modules was lesser of a cost than installing single axis tracker. Way back in 2015-16, that's what we saw. So instead of going for a single axis tracker, we decided to do 20% extra DC capacity than installing. The results would be better, and there wouldn't be any affiliated O&M costs involved. But today, the things have changed, and with the bifacial modules and single axis tracker becomes a very good combination, delivering you very good LCOE. So that's all from my side, Amresh. No, you are on mute. Amresh, you are on mute, apparently.
Yeah, thank you very much, sir, for your inputs. So I think you raised a very valid point on structure weights being, coming down from 50 tons to now approximately 20 to 25 tons. So let me go to Mr. Santosh Patil from Ganges. I think they're pioneer in making structures. They are doing trackers also. So seeing this journey of 50 tons per megawatt to 25 tons per megawatt, which Mr. Sanjay Nulla said, and uh, evolution of trackers to suit the Indian industry. So, what are your views going forward? How this growth mechanism will take place, and where do you see this parity coming, wherein everyone will have this sense of even not thinking of creating a solar plant without trackers. Right now, we can see people still thinking over it whether to do or whether not to do. So, as Mr. Sanjay said, when the time will come when actually no one in India will think of a power plant without a tracker. Single axis or double axis, that's a different thing. But at least, like, you cannot assume a power plant without an inverter or transformer. So when the time will come when Indian developers will not think of a power plant without a tracker. So what's the timeline you're seeing for that?
Thank you, Mr. Amrish. And as very well said by Mr. Sanjay, the journey when we started solar way back around 9 years before, the fixed tilt structure was being done approximately at around 90 to 100 tons per megawatt. And we were the company who brought in that 100 tons per megawatt to 40 tons per megawatt by using the cold rolled sections. Then later on, the steel grade was changed, and then new engineering methods were decided, and then we started talking about weights like 25 tons or 26 tons per megawatt. But always we kept in mind when we designed the structure, was not our only motive. It has to be a mix. One is the right combination of the loads, then the site requirements, the terrain requirements, everything has to be considered. Apart from that, including the foundation also has to be considered while designing a structure. If I reduce the weight of the structure, the number of foundation will increase. So we have to have the right combination to understand what suits best. Then came seasonal tilt. Seasonal tilt, we were the one who started seasonal tilt structure. But seasonal tilt has its own limitation. It's all a laborious job being done by all laborers throughout India who doesn't know like how the body will behave, how to lift the structure, how to fasten it, how to bolt it. Single and technology coming to India, it was there, but again the developers and the people who are doing projects didn't believe in that technology. Maybe it was nascent to India, and secondly, how to do the O&M and whether they will be able to get that generation. Also, there were reports of some plant failures. But if you see the US and Europe, you can see single axis tracker is the one which is being put majorly, including now China also. So now technology on its own has created and ensured that yes, it is the most safest you can say, for the modules, and people can rely on that. Once it is being tested for all the loads and the right bankability is done, then there is no problem in using the single axis tracker. Then when you come to like, why people were not using, one is, module prices were low, the other components prices were low. So when we discussed about single axis tracker to people, they told like by adding more structures and more modules, we will be able to generate more than that. But now with the increase in price of modules, increase in the cost of other materials, like steel is at highest now. So and the tariffs are the same. So now people have to understand that yes, single axis tracker with bifacial module or the module with higher watt-peak capacity has to be used, so that with a small, like we have done a calculation also, with a small variation of say around 7% more cost when compared to the fixed yield, people are able to get around 6 to 7% more generation. So that means with around 7% more, if they are able to get say 14% or 15%, so they are able to get that 7 to 8% more generation with the additional cost. So definitely it will improve their ROI. That has already been realized by the Western countries, and they're implementing it. And India will soon, as per our, like say for example, the current year for the people to start looking into single axis tracker, and next year onwards, I feel that most of the plants which is built in India will be with single axis tracker.
Thanks, Mr. Santosh. Thank you very much. I think on this note, I have to go to Mr. Rishi Mishra, because he raised a very interesting point that in India, trackers were not being used because the prices were low. Now, it's very, very interesting, and since you are in procurement as well as in engineering, so very dangerous statement for you, because everyone wants the module prices to be as low as possible. So if that is the reason for usage of tracker, then it's a volatile market actually. There'll be days when actually the prices will be very low, and there'll be days when prices will be not so low, like it's happening these days. So are we thinking that when the prices will be low, then India will not be using trackers or vice versa? So this is one thing which I want to input, which I want to seek from you. Another thing is, see, ultimately, if you pure on a financial model, if you see the use of trackers, then the price of trackers has to come from, number one, the excess generation. Second, the saving in the balance of system. So what do you think, as on today, with the prevalent module prices and the prevalent tracker prices, does it make a good business case for you to go to plants with tracker 100%? So what are your views, Rishiji?
Thank you, Amresh. Actually, my view is a little bit different than what, not, I will say a small difference than what my other colleague has conveyed. The reason why I'm saying is because when you see the module prices is going up, we recently evaluated whether we will look for the tracker having a less modules, equivalent amount of generation by using the tracker bifacial module with string inverters. But when we started evaluating that, what has happened, because of the commodity dynamics, what has happened, the raw material price has gone up. And the steel prices is tremendously gone up. And the tracker also, you see, compared to the fixed steel, the tracker also uses almost a close to 15% extra steel, 50% extra steel. So because of that, the current situation is that the tracker is also not becoming a viable solution. That is one part. Second issue is it is not only the steel price, but also there is a basically inherent cost which involves about the communication part, about the some kind of the IP which is involved in the tracker. So that also we need to see that what kind of support we are getting from our tracker supplier. These two parameters which drives the choice to go for the tracker or drop it. Now this is along with these, there is another component also which is also the major component is about the land. Because many times what is happening, because of the tracker, the the effective utilization of land is going down. So we need to also evaluate that what will be the land cost, and if the land cost is reasonable or it is lesser, that also drives the tracker technology. But going forward, in any project, if you take it 100% tracker, still I don't recommend. Why? Because effective utilization of the land will not be there if you are using 100% tracker. So what I am suggesting, even if you decide to go based on certain circumstances, even if you are achieving a better IRR, please evaluate the case with some usage of almost 90-95% of the tracker, and maybe balance fixed 5% of the fixed tilt structure, or maybe seasonal tilt. I don't recommend a seasonal tilt, but I will recommend the fixed tilt structure, because what has happened, tracker having a longer length, orientation of east-west directions, corner of the lands, because when we are talking today in India, most of the projects are almost in a couple of megawatt capacity. When we say couple of megawatt, means 100 megawatt plus all the projects are targeting. And when we are targeting such a larger project, you will not get the regular shape of the land. 100% of the tracker leads to an ineffective utilization of the land. So to effectively utilize the land, what I suggest, please evaluate the options with a maybe 90-95% of the tracker, and the balance 5% can definitely should look for the fixed tilt combinations. With this, you will be able to better utilize the effective, get the better utilization of the land, and also reduce the capex. So that means when we talk about the IRR will be better if you are using the combination of that, not the 100% of the tracker. That is one part. And of course, all the thing is driven by only the what kind of IRR you are looking for. And IRR determines by what will be the module prices, what will be the BOS cost, because many times what is happening when we are looking for a tracker, the BOS cost will go up because of the staggered arrangement, and sometimes you are not able to do a stringing, because tracker you will be using a basically positive on one side, negative on another side. So definitely the cable cost, and of course these are the very minor component, but this also leads to additional increase in the cost of the system. But eventually all this will be derived only by the IRR. If you are able to get better IRR, then you should look for the technology. And the better IRR in tracker can happen only when you are able to get the less reduction in the structure prices and less reductions in the IP, basically the kind of the IP loading is coming on that. But more importantly, if you find that significant improvement in value chain, definitely that will be more driver. And currently we are finding most of the tracker component, of course, except some of the major structure part, most of the tracker component is getting imported. So unless we indigenize these component, we will not be able to see that kind of push in the tracker. And if we keep on importing more component, we are liable to pay huge taxes, because many times what is happening, because of the custom duty also, business cases is getting dropped down. So that's some kind of brief insight about the tracker versus fixed. Over to Amrish.
Thanks, Rishiji. I think at this point I have to bring in Ganesh. So Ganesh, Mr. Rishi Mishra is very candid in saying that the time is not ripe for implementing 100% tracking system. So, but I'll come to a bigger question. So, why it is happening that whenever I meet a representative from a tracker company, so they're convinced with financial models, they're convinced with technical logics that going ahead with tracker is actually beneficial in terms of LCOE, is actually it doesn't eat away on the IRRs. But if I hear the same analogy, same statement from a developer, so they have the totally reverse or totally opposite of what the tracker guys are saying. They're saying no. As on today, the IRRs take a dent if we implement the trackers. The return on investment is not that good. So why you're not able to convince the Indian developers that look, the LCOE improves with trackers? So what is the reason? Is there something wrong with their understanding, or fundamentally they are right, but you're not able to find some middle path in between? So what are your views on that?
Thank you so much, Mr. Amresh, for this important question. So most of the time we are facing the same difficulties which you highlight here. So all the clients are raising concern whenever we are trying to convince them to use the tracker. So they are raising concern, if we buy tracker, we need to pay some additional cost in the beginning. And later on, we need to pay additional cost for the O&M. So these are some critical issues which they always raise. So here I would like to inform, whenever you install the tracker, definitely you will get at least 13 to 15% generation. This is number one part. Another part, you will get additional at least 3 to 5% gain because of the bifacial if you install bifacial plus Skyline solution. So definitely there is additional gain, but another side, definitely you need to pay some cost. So as Mr. Sanjay Nirula mentioned, there is a learning curve which we always follow from the Western countries. So if you follow the US, Australia and Middle East market, on those regions, almost around 50 to 70% projects people are installing with the tracker. So here basically we need to understand, we need to test the technology, we need to test the supplier, and then we need to clearly calculate the IRR. Because see what is happening, many times we have seen developers are very conservative when they are calculating the IRR. They are not putting the aggressive parameters in the IRR calculation. They are always thinking in the tracker, there is always a rotating part, and that part is rotating at least 12 to 20, 12 to 18 hours. And if we use those trackers technology, definitely there is some loss, there is some failures. But we have seen, since we have approximately more than 10 gigawatt of installation, so we have seen that these things are not happening regularly. We have oldest site around 5 or 6 year old, and that site is also continuously working. Even in India also, we have project in Tamil Nadu, one of the biggest site, 172 megawatt. So that site is continuously working. Normal, some small maintenance is required, like lubricating oil, you need to change, some fastener tightening required, but there is no major failures like motor failure or communication part failure. So the thing is only, we need to understand the technology, we need to trust, and if developers trust, definitely there is no such thing is going to happen in the tracker technology. And this is the most renowned technology, and all the leading companies in the world, as I already mentioned, US, Europe, and Australia, people are continuously using those technologies.
Thanks, Ganesh. So let me call upon Mr. Ravindran Sundar Singh from SoftBank Energy. So, Mr. Singh, my question to you is: are we so engrossed in tariffs? Are we so engrossed in IRR? Are we so engrossed in, one day the tariff is 242, then 220, or then 199? I mean, then we miss out on the bigger picture. We miss out on the technical aspect, because sun is a mighty monarch. It gives you infinite source of energy, so it is up to us to extract the maximum energy out of it. And tracker is one way of extracting that energy. But the way we do our financial modeling, the way we give prominence to the figures, the pricing, the tariffs, and everything. So are we really missing out on the bigger picture? Because if you see plants outside India, in Middle East or in Europe, so now majority of the people have started their building their plants with trackers. So why we are so indifferent? Why we are showing so indifferent behavior? So is it really commercial, or we're missing out something? Mr. Singh, are you there? I think I can ask the same question to Mr. Dinesh Thakur. So from CleanMax. So Mr. Dinesh, are you there?
Yeah. Yeah.
All right. Yeah.
Yeah.
Please.
So yeah, it's a nice view from the Sanjay sir also, Rishi sir also. But I would like to say that in the recent trend, current trend, we are facing the module cost, which are drastically increasing. So why cannot we draw out as maximum energy from the module? So it is only possible with the single axis tracker. With a bifacial configuration, obviously, because if you compare with the fixed tilt, the single axis tracker is already can achieve 16% higher generation, 16, and with a bifacial we can calculate up to 20-21% higher generation. So in my perspective, if we have to improve the IRR and reducing the LCOE, I think tracker is the best option with the current trend.
Thanks, Mr. Dinesh. So my understanding from the panelist is, sorry, I missed out on Sangeeta's message that Mr. Singh is down with COVID and he'll not be able to join. So we wish him speedy recovery. So I think after speaking to all the panelists, so I am of the view that yes, tracker is must for power plants. Tracker is, going to be a part and parcel of our power plants, but it is relying somewhere, on the tariffs, somewhere on the financial modeling, somewhere. So that is actually that is not actually um, letting it grow with respect to the growth in the solar sector. So my last question to Mr. Sanjay Nrula is, do you really think the trackers are priced in such a way that developers are not feeling comfortable in building their financial models around it? Do you really give a message to companies like Arctic and Ganges to make it fairly priced, or it is just our apprehension that we are not able to adapt to it? So what do you think the main reason is? It the pricing, or is it the volatility of the market, or it's just something not coming from our inside?
I think every panelist has shared very pertinent views and given some good insights into the dynamics of whether or not solar single axis tracker or trackers per se are user friendly for the developers or not. So given those inputs, so what comes to my mind is definitely definitely the trackers at current price are not priced at what they should be priced at. They are higher priced, definitely because of some of those electronics parts, including actuators and those motors and the communication system, which is still getting imported, and a lot of duty is getting levied on them. So I think there are two key components of a tracker system. One is the steel cost. They get impacted by the international steel price. And the second would be these electronic components. Now, having said that, steel price is not in our control, so it will change the way it would change. So you don't have much control on. But definitely something that we can control is the other part of it, which is electronics and the jaburi of things that comes along with the steel. So that is where the opportunity lies in reducing that price, because as of today, also a price of 50, 55 lakhs, in the range of 50, 55 lakhs or 60 lakhs. I don't know. I don't have the exact price right now with me, but it is anywhere up close to 50 lakh rupees per megawatt, is much higher than what it could be or what it should be, given the indigenization and efforts that should be deployed on indigenizing the electronics part of it. Like ASN referred a very good case, although he took more time, Mr. Varun Sachar, but quickly he talked about his collaboration with IIT and developing a new kind of a solution. So similarly, I think some technology savvy companies should tie up with R&D institutes and develop all those kind of wherewithal and set up in India, so that the pricing can come down at a point where it becomes, so much of it becomes a lucrative thing to deploy a single axis tracker irrespective of module pricing going up by 5 cents or coming down by 3 cents, irrespective of that, it becomes a, go situation. So that's what I think. There's definitely a scope for price reduction.
Thanks, Mr. Sanjay Nurla. So I think it's a food of thought for both Ganesh and Mr. Santosh Patil. So at this point, I hand over to Sangeeta, who can start the question and answer session.
Sir, we have received few questions in the Q&A box. So if you could please take up the last few questions.
So if you want me to take the questions, I can pick few of them and direct to the panelists. Is it okay with you?
Yes.
Yeah.
Yes.
So
Yes,
sure.
Great.
Yeah. Okay. So I think I'll take the first question. So it is from Sahil Batra, and I think Mr. Rishi Mishra can answer that. So sorry, it can be answered by Arctech. So how tracker manufacturers are compensating rising steel prices? Is it a challenge for the industry or a manageable thing? So Ganesh, you want to take it, or
yes,
Santosh?
No problem. If you want, I will answer.
Yeah. Okay. So let's Ganesh.
Okay. So thank you, Sahil, for the question. So see, definitely steel pricing is something which we are not able to control, and definitely if steel price increase, definitely tracker price will also increase. So still we have a limit where we can control up to the 15 days. So if we offer any price that can valid up to 15 days, so we will make sure within 15 days we cannot change the price. And the second thing, if you ask us to how we are managing the steel price, so we maintain some inventory to manage those steel prices. But frankly speaking, we don't have control. So if steel price increase, definitely tracker price will also increase.
All right. So there is one interesting question from Kumar Mukund. So I'll direct this question to Mr. Rishi Mishra. So the question is, don't we have enough case study available to support the claim on gain in ROI by implementing tracker technology? So Rishiji, want to take it?
Yeah, Amresh, can you repeat your question again, Amresh?
Yeah, so the question is basically, don't we have enough case studies to decide, with implementation of trackers technology, so what could be the ROI? I mean, we are always speculating. So enough historical data is available with us or not?
I will tell you, when you really talk about the ROI or IRR, these are all case to case basis, because and especially in the present dynamic condition, when you are finding that today you are finding the structure price, it can increase by 5% in the next day also. So when you have so much commodity variation, and this is not only on the structure prices, the same case is happening in terms of the module prices also. When you have so much dynamic conditions, you need to generate each and every time, you need to generate a case studies, you need to generate a basically not case study, you need to generate the models which can suffice the your, or which can justify your decisions whether going for tracker is a viable solutions or it is to go with the conventional options. But if you really talk about in terms of the case study, there are ample of case study which is available, which can talk about different perspective, different drivers with a different perceptions. So you cannot, whether this is applied to us or not, that we need to evaluate the case, because in India especially, a lot of challenges is happening in terms of the interest rate, in terms of the high initial capex, because we have found higher capex is almost leading to a no-go solution in many of the options. It may be a good options in the other country, but may not be applicable in India. But moreover, what I am suggesting, the last option is, I found that the people are, the one is about the commodity prices. Second one is about the conventional way of approaching and addressing the solutions, because we keep on operating with a fixed type of structure. People has basically enough experience towards that, and that is why they keep on operating. But the kind, when we started talking to the different technology or maybe some kind of tracker vendors, they come with basically a lot of limitations. They don't basically offer the, in terms of the performance guarantee. They always talk about the availability, which is also sometimes it's a basically a restraining forces towards the technology. So I think going forward, definitely these are the constraints at present. But going forward, depending upon the situation, if the commodity keeps on changing, we may see in coming year the tracker may viable or may not be viable. But very difficult to generalize the thing and say that the tracker can be the future. It can be, cannot be, depending upon how the commodity price is moving.
Thanks, Rishiji. So I'll take the last question. So Santoshji, you can answer it. So it's question from Sahil. What kind of maintenance is required with a tracker plant? Can you please mention some high maintenance parts? So can you take it, Santoshji?
Yeah, Mr. Amraji. Thanks, Sahil, for the question. As I already told, the old trackers, which we also initially did, was with the actuator, and with like say the since the size of the row was less, that is, say for example, one row was able to do around say 100 kilowatt. The number of parts were more, which required more maintenance. But as I showed you the new tracker, what has been developed, it is like a fixed tilt structure which is rotating, wherein the parts which are being used are like the wire rope and slew gear and a motor. So wherein these motors and these slew gears are built in for say so many rotations, which will run for say without maintenance, say for 7 years, 8 years and all. So that is the kind of tracker wherein we need to invest, and we need to see that where we can invest to bring down the cost also. So the tracker what we are trying to bring in requires very less maintenance. The maintenance will be like say the frequent tightening may be required after every 1.5 years or 2 years of the structure, because there will be vibration and there will be rotation. Apart from that, we don't see any maintenance part. That is the simple thing what we have done in this kind of tracker. Otherwise, with the actuator type, whether it's a mechanical or a hydraulic one, there are often issues with the seal, with the oil, with the gear. And since this, like say, one rope is sufficient for say 400 kilowatt, that is 1 megawatt will be 2.5 rows. The number of parts are also less. Say if you can keep some small spares of say motors, it will run for years.
Thanks a lot, Santoshji. So I think with that we conclude this, and once again I thank all the panelists, and paying homage to all the health workers and all the people who have lost their lives, and encouragement to all the health workers, and appreciation to all the people who are working for us in the field. So I hand it over to Sangeeta. Thank you very much.
Thank you so much, all the key panelists, for your valuable insights. Amrit sir, thank you so much for moderating today's session. With this, we will proceed ahead with the next panel discussion. But before we do that, can I request my team to play a few informative slides from RR Ispat?
Thank you.
Thank you. Now we'll proceed ahead with our second panel discussion. The topic of panel discussion is structures, trackers, and mounting systems for rooftop projects. Session experts who have joined us today are Mr. R. Venkatraman, who is the director from CleanTech Solar, Mr. Dinesh Thackeray, who is the head design and engineering rooftop from CleanMax. He would also be moderating today's session. Mr. Anurag Bide, who is the chief operating officer from Solar Square Energy, Mr. Aman Gupta, who is the Assistant Vice President from Ampless Solar, and Mr. Deepak Danija, who is an Associate Vice President Marketing from RR Ispat. I would like to hand over the session to Dinesh sir to take the discussions forward with other speakers. Thank you.
Thank you, Sangeeta.
Requesting all the speakers to kindly start their cameras and unmute themselves. Thank you.
Thank you, Sangeeta. Welcome, everyone, for this great session. So after the utility scale installation system, we are just moving to the rooftop system. So we have a abundant roof space available, which is currently not utilized by the industrialists. So same that space we are using for the solar installation to generate the electricity for their own consumption. So I would like to proceed with some panel discussion points like the effective structures of the rooftop solar project, which we need to build for the 25 years, what parameters we need to check. So I would like to ask the question to Venkatraman sir. So while designing the structure, what parameters we need to consider which can sustain up to 25 years?
If you're talking about rooftop, there are two scenarios. One is the large sheds, the commercial sheds, and the other one is the RCC roof. Now, if you're talking about the PPG sheets where they use for factory sheds, there, of course, the 25 years, what we are considering is assuming the sheet condition is good, because there are a lot of technologies people are talking about. One is so far, though 2 years back, 3 years back, there are a lot of talk about bonding technology where you don't have to really use a rivet or drill the sheet. But somehow or the other, that we have not seen has gone up in a very large scale. It was there. Some people have used it all right, but we don't hear it being used in a very large scale. But the problem which is there, of course, we all say that it will last for 25 years. Now, the sheet condition, unless it's a new sheet, then certainly, yes, it will. Now, if the sheet is already, say, 10, 15 years old, and you go and install a solar plant on top of that, and you are drilling the sheet, of course, but the corrosion of the sheet inside, you don't know what's happened. It's a coating, outer coating only, you see that how good it is. There are cases we have done a test also that over a period of time, you will take out where you are drilled this rivet, and you take it out and see there is a corrosion which happens inside, because the water somehow the other seeps inside and it starts eating at the sheet. Another point is that in Europe and all, they use the PPG sheet with the coating, which is 0.9 mm thickness, whereas ours is only 0.4, including the coating. That's the whole point. Yes, we don't have a history for 25 years. Yes, certainly what we design and, we take into account in the wind factor and everything, and depending upon the region, we do take into it. Of course, the aluminum structure, nowadays we're not using the steel rails or short rails we are using there on the roof to minimize the cost also. So we have not an experience that 25 years will last, but the design is for 25 years, assuming the sheet condition is good. Because if you have done your costing, if you have done your IRR on the basis of 25 years, and suddenly the owner takes away that, okay, after 5 years or 10 years, he's going to change the sheet. Now, that's why we provide in the PPA when we are basically a developer. CleanTech does not get into capex model. Yeah. So what we do is we do take care in the PPA that a condition that in case the customer or a client decides to change the sheet and all, the replacement cost, the dismantling cost, and reinstallation cost and all, we keep a provision for, that they take that cost. If that is so, yes, I mean, the time lag will be there, and that also the time loss of production. We take a deemed generation, and then the customer is supposed to pay for that. So that's how we make sure that for 25 years, it should last.
Yeah, thank you, sir. So means basically we are considering it is a coastal area and non-coastal area with the RCC metal roof, and the stability of roof is also important factor while designing the solar system. Sorry, sir, your voice, you're on mute.
Yeah, absolutely. I think because I don't think the PPG sheets, the coastal area makes much difference to that, because the coating on the sheet is supposed to last for 25 years. That's what, whether it is JSW or anybody who supplies these sheets do guarantee it well. But some of the other, the usage of it, probably the maintenance of it, many companies don't maintain it, it gets exposed to all weather condition, the corrosion starts. So it all depends on that.
Exactly. So mainly we need to find out means key risk and causes of failure in the effective structure design. So I would like to ask Mr. Anurag that what key risk and failure causes we are considering at the time of engineering of the rooftop solar structure.
In terms of the risk factors that we consider for structure design, I think it is a twofold problem, not purely a design aspect, as well as there is a manufacturing or raw material supply aspect also associated potentially with failures of structure systems. In terms of the design, I think there are several structure manufacturer suppliers, especially in the aluminium structures segment for metallic sheet roofs in India. And largely all of them are providing stability reports or STAD reports that claim that the structures conform to the wind load parameters for the specific installation. However, it has been observed that there are several deficiencies in terms of the understanding of how the STAD analysis needs to be done, the factors to be considered, and there are a few malpractices in terms of how these things are applied. So it actually makes sense as a developer or as an EPC to actually get the STAD report evaluated from a credible structural engineer who can actually say with certainty whether all the factors that need to be considered have been considered in terms of the evaluation. In certain cases, for aluminium components, it may make sense to go for FEA analysis of the components as well. Since the STAD Pro software is typically for a integrated system and is more suitable, let's say, for the ground mount kind of structures as opposed to aluminium structures for metallic rooftops. The second aspect with regards to the risk of failures, I would attribute to the material that is supplied. I mean, even if the design has been evaluated and found to be, corresponding to the wind loads and other loads that are being imparted on the installation. With regards to the material supply, it would always make sense to check both the chemical composition as well as the mechanical properties of the material being supplied. For instance, in the case if we talk about aluminium, largely it is aluminium 6063 grade, which is commonly used now widely across the industry for metallic sheet roof structures. Having said that, it is critical to understand where the raw material is coming from, whether scrap material has been used in the extrusion process for the manufacturing of the aluminium. And sometimes these things cannot be picked up purely from the chemical composition analysis as well, because even where recycled or scrap material has been used, they may pass the chemical composition test, but it is essential to also check in parallel the mechanical properties or the hardness of the aluminium, because typically there is a tempering that is done which provides the hardness to the aluminium structures. And if there is a component of scrap or recycled aluminium within it, even for the same tempering, you may not be able to get the same mechanical properties or the yield strength that grade is supposed to provide. So in that sense, I would put this as a twofold problem. Likewise, in the case where perhaps in the RCC roof installations, wherever steel structures are being used, it would make sense to have the chemical composition and the mechanical properties of the material supplied tested to ensure that the material grade actually conforms to what has been considered in the structure design. So I would look at it as a two-way problem. One where the wind load and the other load considerations have been considered correctly and applied correctly in the structural analysis, and two, where the material that has been supplied actually conforms to the metal grades that are recommended based on the design.
Okay, exactly. Yeah. In the FEA analysis as well as this quality check, so we need to be cautious on this. And in addition to that, in India, we are still now we are considering IS 801 for the designing of pre-gal section and galvanizing section design. So where the global buckling effect is already considered in the IS 801, but the local buckling and distortion buckling, which is exactly not considered, which is the exact reason of the failure of structure. For that, yeah, mainly American standards, which are already updated one, upgraded one. So the recent American Standard Code, which included all those buckling effects. And with this, yes, obviously we have to consider the quality checks and quality analysis of the material as well as their processes. Yeah. So with this, Mr. Aman sir, yeah. So we would like to hear you from that learning from the some case studies, which is like rooftop failure, rooftop solar structure failure.
So when it comes for case studies, there are many things. I mean, I'm sure the colleagues, Mr. Anurag and Venkatraman sir, have already highlighted the issues that pertain, that eventually lead to such kind of failures. The material, for example, the codes prescribe 5% tolerances, but when you put a 5% tolerance on a 1.5 mm thick steel section, you essentially are reducing 5% from the strength. And we are already on a STAT analysis or any kind of FE analysis, we are already near 0.9 or 0.95 to the utility ratio. So that is one thing. Second things, the case studies, if you want to hear, there are many issues like the understanding of the codes. So you mentioned the American codes, but American codes, not everybody is understands it pretty well, and it is easy to play with, because when you go to a chartered engineer to vet it, he also does not understand, and he takes a lot of time to do it. So scalability becomes an option in such cases. Third thing, and even for the IS standards, people have, because these standards are made for first thermal and infra, then they were used for hydro, and now they are being used for solar. And solar being very, very small part of it, they have a broad boundary conditions, and it becomes a very huge area to play with. So the structure that you're using for a location like Delhi, if you're using it in Odisha, or if you're using in Gujarat's coastal areas, it becomes a recipe to failure. We have seen Vayu, we have seen Fani, all kind of cyclones, which ultimately change their paths. And if you see the wind velocities that they encountered, they were more than what IS codes prescribes. So that is one issue. Then comes to coastal areas, even the best kind of steel material, new technology materials, also write in a small version that please do not use these in 10 kilometers of the coastal areas or near sea areas. So that's also becomes an issue whether you can use it. So those are some kind of case studies where sometimes you learn by failure, you use them, and then you realize. We recently came across a project where the due diligence was done, everything was done, and still we missed out on the small aspect that when we actually went to start the engineering and saw the actual site, what we could witness was the corrosion was so high because it was a chemical industry. It was they were essentially making paints and such kind of products. The corrosion was as high as the structure would start rusting within 2.5 to 4 years. Now, on a system like that, how would you put a project? You cannot just say no. I mean, saying if you start saying no in such kind of industry, you essentially lose on a big category of customers. So that's another thing. There are further case studies like you have to segregate a properly pre-engineered, a properly designed and erected pre-engineered building versus a locally shed, even for esteemed AAA rated companies. So that also becomes a challenge. You visually see it, or whether you go for an analysis. And we have come across many cases where many prestigious companies, including MNCs, the building essentially failed when we did a stability analysis, and they were in fact failing even without solar. So if you put a solar, you put an additional load of 15-20 kgs per square meter. So that becomes a challenge as well. So it has, I mean, rooftop solar is essentially a retrofit, if as we like to believe. As compared to a greenfield ground-mounted project, it's a brownfield project, and it has its own set of challenges. You sometimes the clients, because we also take part in residential solar segment, which is a small vertical in Amplus Homescape. So there too we come across wooden structures, we come across bamboo sheds, we come across which are very common in hilly areas or semi-urban areas. So those kind of things. We also come across old heritage site at times, and these are RCC buildings which you see. But when you actually go back and check it, some of them were built in 1916, 2 years before concrete was introduced in India. So how do you put a system on that? That's a challenge. So such kind of case studies are there. Whether you choose or you take a conscious path of innovating the system by not compromising to the integrity of your system as well as the asset on which you are placing it. So that's the real game and entertainment.
Okay. So crux of that, so we need to be cautious about the design code as well as the wind zone and building height, seismic zone, salt spray test, and if it is coastal or rusted area. So for that, we have to use aluminum structures.
True. And sometimes with anodization.
Yeah, obviously anodization, again, that is the anodization layer varies according to the atmosphere.
Exactly.
Yeah.
No, so when Anurag sir mentioned T606, I mean 6063 grade, the second part of it, which is T66 or T5, that also becomes very important area to area. Yeah.
Now I think the POSCOM has come up with this thing. They claim that, of course, it's self-healing material, and
POSMAC.
Yeah, POSMAC.
Yeah, POSMAC.
But sir, POSMAC also has a set of limitations. That's 10 kilometer star mark is actually from POSMAC only.
Okay.
For that matter, galvalume also sometimes say it.
Galvalume, of course, galvalume. Yes, but POSMAC, I thought it's a self-healing material. That's what they claim.
True.
Exactly, the galvanium material is really good, better than the pre-gal structure or HDJI commercial.
Another factor which for RCC roof where it can fail is many industries or people don't want to puncture the roof. They insist on doing a ballast system on top. A ballast system is something you can scrape and you can use the Nitobond, and it's a good, of course, though Nitobond claims that it's stronger than the mother concrete. When you apply that, this thing, alien concrete is stronger than the mother concrete. But it does, it all depends upon, as Aman said, it all depends upon you design a system for, say for 40, 47, 49 meters per second. And if the wind velocity goes, in a gush wind about 200 plus, it can happen.
Sure.
There it doesn't hold, then it gives up. That's a whole problem that can create.
Exactly, yeah. So anyhow, with ballast system, there is a panel clause system and all those things are designed. But again, there is a doubt about the eccentric load consideration.
Maybe I would say Panaclaw system is much more reliable than a ballast system where you're sticking using little bond.
Exactly. Yeah. So,
another major consideration actually with regards to the NATO bond part is a large number of installations. NATO bond actually needs to be bonded to the base RCC slab, and in a lot of cases, particularly what we are looking at in residential installations, by a lot of local EPC players, the bonding is actually being done on top of whatever the waterproofing layer is there, on top of the RCC slab. And since the clients do not permit to remove the chip away the RCC layer, ultimately you are relying on the strength of the waterproofing layer on top of the RCC to ensure that your concrete block is being bonded to the base substrate.
See, most of them, Nitabond, though it says that the different grade of Nitabond, and the right way to use it is that probably call them and they take the concrete sample and then suggest you what grade should be used, which mostly people don't do it. Okay, common man say, okay, Nitabond laga diya, theek hai, it's all finished, and that's where it.
Exactly. So, while designing the foundation for the RCC roof, we have to consider NATO bond as well as the counterweight ballast. So, that is also important one.
Is I think if you can, you see there are. What happens is there is a RCC layer which is normally about 100 to 120 mm, and over that for heat resistance, they put a mud pack or something. On top of that, they lay a brick layer, two layers. The ideal thing is that you go down to the RCC and at least go for 10 to 15 mm or 20 mm down. Use a longer fastener. Then it is safe. Nothing happens. The idea is that if you don't go and touch the RCC bed, then it is always a risk factor, which is.
Exactly. So even though if you have to use the elevated structure also, then there are some options which is readily available in market, like a rebarring of the existing building structures. So by using some chemical bonding agents, we can do the rebarring without any leakage issue.
But normally, I think the chemical fasteners are reasonably leak-proof.
Exactly, yeah.
Chemical fasteners are reasonably leak-proof.
But that awareness has to go to the customer segment as well, because
they are very skeptical about it. That they might puncture the roof and leakage would start in the.
So, yeah, as a developer, Venkatraman sir, I would like to ask while going for the rooftop installation, what exactly basic parameters you are cross-checking or verifying with the roof, or we can say the load-bearing capacity of roof and suitable structure based on quality of roof.
This is a very important question you're asking, because many industries are 15 years old or 20 years old, and they don't have the structural drawings with them, or what load it has been designed to. Of course, nowadays, the new structures they are already taking, into consideration the solar load into that, which is normally they're taking about 15 to 17 kilos per square meter, or point load of 2.5 kgs per point. Now, this is one thing, but mostly what we are doing is, to the extent possible, we hire a consultant, structural consultant. If the drawings are not available, data is not available, we do our own this thing depending upon the existing structure there. We go and see the structure, how good they are, what is the corrosion, erosion or corrosion taken place in that. And we suggest to the customer that if a replacement or some sort of a modification has to be done or strengthening has to be done, then we ask them to do it, and then we do it, because there is no point in taking a chance that straight away in the purlin, you just drill the hole and put the structure. And if the purlin doesn't have the strength, then it's bound to blow off, and it'll take the sheet and fly off. So we never do or install this thing, solar system on top of any roof, this thing, factory sheds or anything, unless they have a structural design, structural data available, all the drawings available, or to the extent possible, we hire a consultant, go there and study the whole system, and find out, satisfy ourselves whether the structure is good enough for 25 years. Otherwise, generally, if they're not prepared to do the modification, then we take it in our cost, which goes phenomenally high. Then we tell the customer or the taker to do the modification. That's what it is.
If customer will not allow, then if customer will not accept that modification in their roof, what you will suggest?
So we are prepared to take that cost, but then we add it back into the tariff and then tell him this would be the tariff.
So same question with Anurag.
All we accommodate is that upfront we don't charge them. We'll say that, okay, we'll spread it over about 15 years or 20 years of your tariff, so that you don't take the immediate impact of that, and the tariff marginally increases.
So the same thing, Mr. Anurag.
Sure. I think just to add to Venkatraman sir's point regarding the older industrial sheds where the design drawings or structural drawings of the sheds are not available with the end client. We had an interesting case where aside from the load bearing capacity of the shed building structure not being known, there were additional considerations that needed to be taken, because in a lot of these older industrial or factory sheds, there are internal loads that are imparted onto the roof structure as well. So there may be an EOT crane inside the shed, which is actually imparting a load onto the structure. There may be a false ceiling inside the roof structure, which is actually suspended from the structure. So these things actually subtract from the load bearing capacity of the building as well. In that particular case, we had worked quite closely with the chartered engineer hired by the client in that particular case, where they had evaluated the load bearing capacity for the building, and it varied from point to point within the same shed. I mean, the shed was probably about 150 meters long and maybe about 40 meters wide. But we had to avoid the last two purlins on both sides because there were some suspended loads, exhausts and stuff, which were reducing the load bearing capacity there, as well as we had a 40-meter section of the entire roof, which had a suspended false ceiling attached to it, which eliminated or reduced the load bearing capacity there. So some kind of middle ground can be achieved in cases like this, where certain portions of the roof can be utilized where the load bearing capacity is available, and a middle ground in terms of capacity can be arrived at. Another thing that has been commonly observed is typically these older sheds generally have had asbestos or cement sheeting in the past, which has been replaced with your metallic sheeting. So there are a couple of considerations that typically the way the load bearing capacity is analyzed there is, since your metallic roof sheeting plus the 15 odd kg per square meter load from solar, whether that is under the load that was imparted by the asbestos sheeting. And in typically most cases, you would find that this is the case. So that is another thumb rule that is typically used by structural engineers to determine whether these buildings have that load bearing capacity for installation of solar as well.
Yeah, apart from that, I think, Anurag, the span is also a huge this thing, because the span, then probably you start using stiffeners and all, so many things. Yeah. So these are the other things which chartered engineer, structural engineer looks into, and we totally go. We hire a very, reputed firm, whichever it is, and then we go by what they suggest, and we give the complete report to the client also that this is what the status. We clear everything before we really get into it.
So it means first we have to do this structural analysis, and there are some minimum criteria to get it passed. So, like dead load carrying capacity and live load carrying capacity with that metal sheet thickness, which we need to.
We don't have much to say because in India the PPG sheets are 0.4, 0.5. Nobody uses more than that. Now the the manufacturing companies, steel rolling companies produce more than that. Because in Europe, as I told, 0.9 is this thing standard. Here it is 0.4, 0.5.
Exactly. So
that's a big challenge of it. Sorry. No. So that's very challenging what Raman is saying. Sir is saying, because as a developer, you also have to think about the cleaning and maintenance for next 25 years. So people have to walk on those sheets.
That's why we put a walkway,
Yes, exactly.
Before we start the work, the walkway is the first thing. And see, we take all precautions. We have walkway, handrail, and safety. Without that, we don't get into the work.
Yeah, exactly. And the resting of the walkway should be also
on the purlins.
Strength, yeah.
On the structure, yes. But that awareness and sensitization has to go to the customer also, because at the end of the day, the person negotiating with you is the purchase guy from that customer, and he says कि वो तो दूसरा वाला भी लगाएगा, and when you go and मतलब.
And that problem is there, because today as a developer, problem you face is the tariff. Tariff decides everything. He doesn't bother. He says, okay, I'm getting 3 rupees or I'm getting 2 rupees for 80 paisa. That's what we have to match. And plus he wants all these things, because once you open those roofs on O&M, they're bound to get dents, and they're bound to get cracked.
Exactly.
So for your own interest, you have to do that. Otherwise, they take undertaking that if it leaks, we have to set it right. So that's why what we do is we do a pre-survey and give it to them. Before we even step on the roof, we take a complete photo shots of inch by inch, and we make a complete this thing and give the customer that this is the status of your roof as of today. If anything goes beyond that, yes, we are responsible not for this. Many times,
you're very right, sir.
When the sheet is overlapping, there is a self-driven bolt in that, that would have come out.
Yes.
So many things. So it is better to do a survey, pre-construction survey, and then give it to them and then do.
So we do another thing. We do a report as well as we do a water leakage test even before starting anything. And anything before that is customer's view. Anything after that is our responsibility.
Exactly. So we would like to listen innovations in the rooftop solar structure, which is lowering the cost. So Mr. Deepak is with us. So Mr. Deepak, just tell us the recent innovations which has happened in the rooftop solar market to reduce the structure cost. Mr. Deepak?
Mute. I don't know.
Mr. Deepak, if you are there with us, if you could please unmute yourself and share your insights. Mr. Deepak, can you hear us?
Yeah, I think.
Sir, I think
same. Yeah, same thing. Yeah, Mr. Anurag, we would like to ask some innovations which are reducing the structure cost, and same thing for Venkatraman sir also.
I think they see the structure cost has already come down, because earlier we used to use long rails, the initial rooftop, what I have done and been done under me. So normally, the rails were long rails, it used to be purlin to purlin. Now they're all short rails, we are using directly not on the purlin, but they are on the sheet itself, That has brought down the cost. The only thing is that I think basically start what we do. I think we can't go below that as far as the material is concerned. It's only the cost of the aluminum, with the international market, how it fluctuates. And like what Anurag had said, the one point is that, if the prime material, the virgin material is not 99.9%, with the source of the material is very important, how you draw it. The process of drawing is same, whether it is a second, used material or anything, but the prime material, the virgin material, what you're getting it from and where you're getting it from and what is the source, that is very important. And not only for the rails, but also for the clamps and all, Z clamps and all, because if those you procure locally, when the wind pressure is pushing it up, it is mainly on the clamps, which is the total pressure is coming. The clamp gives up the modules to fly then, So
Yeah.
really, I don't know, because the cost of the structure totally depends upon your source of procuring them. And if you buy it in the local market, probably you'll get it at the half price, but that's also aluminum, What normally these guys do, they buy the profile and they just start cutting it and then, make it and then supply it. But where do they buy the profile from? They don't give any certificate where they bought the profile from. So cost, reducing the cost is one thing, but what are you compromising it with, because the cost is already quite reasonable, I suppose. Now, I don't know, Anurag, you can throw some weight on that because you're in that system.
Yeah, I think pretty much the same opinion in terms of metallic sheet roof solutions, whether it is your trapezoidal roof sheets or your clip lock or any other ProFlex roof sheets. And pretty much for all of these different kinds of sheeting solutions that are existing in Indian industry, the aluminum solutions already exist, which are tried and tested and proven, and within a price point that is almost has leveled off in terms of the optimization. I think the only fluctuation that happens anymore is because of the raw material costs. But on the design front, there is very limited scope to further optimize, at least in the structures part for the metallic sheet structures. For the RCC case, I think the counterweight ballast solutions are I think we mentioned panel flow from Ganges a while earlier, are also a fairly optimized solution. One place where I would probably say there is potential room for innovation or cost reduction is when it comes to superstructure, where a height needs to be provided to your modules, or a clearance needs to be provided, which is particularly the case which we are encountering in a lot of urban commercial projects, where there are a lot of, let's say, HVAC units or telecom towers or surrounding buildings and stuff which are casting shadows. And the capacity reduces drastically if you, reduce the height of the structure or reduce the module clearance to something like a counterweight ballast kind of an arrangement. And the capacity could increase quite tremendously if you raise the structures to a height of, let's say, 2 or 2.53 meters. But that is one particular space where I believe that there could be room for design innovation and potential cost reductions brought about by design.
Yeah, exactly. For the elevated structure, where many times client asks for the leakage proof also, there is also a huge innovations are there, where we can use the silicon sealant, not only silicon sealant, but with a filler material silicon sealant, as well as some silicon tapes are available for the leakage proof. With that, some trusses designs which are readily available, pre-engineering buildings which are now cost-saving design, which we are finding. Yeah. So last point for everyone, that about the solar tracker system for the RCC roof, for the huge RCC roof. Means I would like to hear from everyone that
that's something, I don't know whether it is possible or not. See, because on the existing RCC roofs, I don't think a tracker system can be installed, because there will always be a dynamic load, which is there. When the tracker is moving, how much dynamic load, you don't know. And where is there, how the building has built, the load has to go down. How it is connected, where it is going to come, and how the load is really traveling in. And plus, I don't know. I mean, has anyone, unless the building is designed, so heavily that it is meant for taking the tracker and that sort of a load, constant dynamic load. I don't think in the existing RCC structure, I don't think. I mean, that would be a very sensible thing to go and put a tracker on a existing RCC roof. I don't know, unless the tracker manufacturers, what they talk about, it's their USB for selling, could be, they can't say anything. Anurag, you are in that field of, you can say.
I'm afraid I don't really have much to add with regards to the feasibility of trackers on the RCC front. What I definitely can comment is, typically in the case of almost 99% of projects on RCC, the focus of the customer is to maximize the capacity, because in most cases, whatever capacity you're able to install in the available area is still going to fall well short of his captive load, which is our observation in a lot of the cases. So where the intent is going to be to maximize the capacity in the limited constrained area, we have even gone to the extent where east-west racking has been installed in a number of projects just to maximize the capacity, since their load requirement is significantly higher than the capacity that we are able to offer in the available area. So in those kind of scenarios, I think the room to even explore the possibility of trackers, where essentially you're trying to maximize the generation out of your installed capacity, as opposed to maximizing your installed capacity itself. When the intent is focusing towards the latter, in most of the cases, there is very little room to actually explore the possibility of trackers, at least in my limited experience.
So, Aman, what is your experience in this?
So we tried this. We tried to do this comparison around 2015-16, when trackers were actually a big thing in India. When modules were very priced, and you would want the highest efficiency and yield from every single module. But what happens is, it's not scalable, and it's not just a problem in India; it's a global problem. It's not scalable anywhere, because this issue will be there of load stability of that RCC. A normal building is not designed to have that much dynamic load, because it is essentially a point load on single column. So how much you do it, no matter how much stability analysis or technical strengthening you do it, it's not a scalable option. That being said, people are still trying to do it. I once in a while, I see new companies coming out in US or Europe, giving out some solutions which try to distribute, making like a tripod or something like that. But given the current scenario, I think the east-west solution, which Anurag mentioned, I think it is a better solution if you want to have maximum yield as well as lower cost, apart from the fixture that we have standardized already.
Exactly. Only government tenders are asking for the trackers.
Right.
Okay. So with this, we are just ending this session. Sangeeta, I think we are open for the question and answer.
So much all the key panelists for the valuable insights. Dinesh sir, thank you so much for moderating the session. We are equally thankful to all our attendees, not just for joining today, but continuously being a part of our event series. So with this positive note, we are ending today's event, and promise you to come back soon with our next event series. So till then, bye from our end, and wishing you all a wonderful and a safe weekend ahead. Thank you.
Thank you.
Thank you.
Thanks, everyone.
Thank you.
Thank you, everyone.